interesting pattern that arises in a specific series of numbers. So if we take 1 followed by a series of 6's as a number and cube it, add 5 followed by a series of 0's and cube it, and then a series of 3's and cube it, we get that number in unit form as those individual numbers next to each other. So the first thing we note is that 10 to the n minus 4 is the same as 9 times 10 to the n minus 1 plus 9 times 10 to the n minus 2 plus all the way down to just 9 times 10 plus 6. So what we're now going to do is split these 9's into 3's plus 6's and expand them. So we get 3 times 10 to the n minus 1 plus 6 times 10 to the n minus 1. Do the same with all the powers of 10, down to 3 times 10 plus 6 times 10 plus 6. Now we're going to reduce a power of 10 in each of the 3's and turn a 3 into a 30. So this becomes 30 times 10 to the n minus 2 plus 6 times 10 to the n minus 1, all the way down to 30 plus 6 times 10 plus 6. Now we're going to collect all the same powers of 10. So this is going to become 6 times 10 to the n minus 1 for this. Now we're going to have another 6 times 10 to the n minus 2 plus 30 times 10 to the n minus 2, which is 36 times 10 to the n minus 2. Now we're going to have the same process, so a series of 36's times the powers of 10, all the way down to just 36. Now what we can do is divide this by 6. And so when we divide both sides by 6, we're going to get 10 to the n minus 1 plus 6 times 10 to the n minus 2 plus a series of 6's down to just a 6. And if we write this out, we get 1, 6, 6, and a series of 6's, where in total we're going to have n digits here. So we also note that 10 to the n over 2 is the same as 5 times 10 to the n minus 1. And also that 10 to the n minus 1 is the same as 9 times 10 to the n minus 1 plus 9 times 10 to the n minus 2, all the way down to just a 9. Now we can divide both sides by 3, and we get 10 to the n minus 1 over 3 is 3 times 10 to the n minus 1 plus 3 times 10 to the n minus 2 plus a series of 3's. So now if we write both of these out in unit form, for this we see we get 5, 0, 0 with a series of zeros where we have n digits, and here we get 3, 3, series of 3's also with n digits. So now we found expressions for each of our original numbers in powers of 10, we can simply plug these in, cube them and sum them and see what happens. So if we take 10 to the n minus 4 over 6 all cubed, this gives us 10 to the 3n minus 12 times 10 to the 2n plus 48 times 10 to the n minus 64 all over 216. If we cube this, so 10 to the n over 2 cubed, we get 10 to the 3n over 8. And finally, if we cube this expression, 10 to the n minus 1 over 3 cubed, we get 10 to the 3n minus 3 times 10 to the 2n plus 3 times 10 to the n minus 1 all over 27. So now we want to sum the cubic expansions of each of these expressions, so we need to make a common denominator, which in this case will just be 216. So this will become 10 to the 3n minus 12 times 10 to the 2n plus 48 times 10 to the n minus 64 plus 27 times 10 to the 3n plus 8 times 10 to the 3n minus 24 times 10 to the 2n plus 24 times 10 to the n minus 8, and this whole thing is over 216. Now we're just going to collect all the powers of 10, which gives us 36 times 10 to the n, sorry, 10 to the 3n minus 36 times 10 to the 2n plus 72 times 10 to the n minus 72 over 216. Now we can simply divide the numerator and denominator by 36, giving us 10 to the 3n minus 10 to the 2n plus 2 times 10 to the n minus 72 all over 6. Now we can rewrite this as 10 to the 3n minus 4 times 10 to the 2n plus 3 times 10 to the 2n plus 2 times 10 to the n minus, sorry, this should have been a 2, minus 2 all over 6. And now I'll just clear some space so we can carry on from here. So now we have this, we can split this up into 3 separate fractions. So first we're just going to take these two terms. So that would be 10 to the 3n minus 4 times 10 to the 2n over 6. Now we're going to take this middle term, 3 divided by 6 is just a half, so we get 10 to the 2n over 2. And then here, 2, we can factor out the 2 here, divide by 6, which will just give us a third. So we get 10 to the n minus 1 over 3. Now, if we factor out 10 to the 2n from here and 10 to the n from here, this gives us 10 to the 2n times 10 to the n minus 4 over 6 plus 10 to the n times 10 to the n over 2 plus 10 to the n minus 1 over 3. Now here we see that this is just this formula, this is this formula, and this is this formula. So we can plug these back in, and what we see is that we get 10 to the 2n times 10 to the n plus 6 times 10 to the n minus 1 plus a series of 6's down to 6 plus 10 to the n times 5 times 10 to the n minus 1. Oh sorry, this should have been a 10 to the n minus 1, and this should be n minus 2. 5 times 10 to the n minus 1, and then finally we plug in this one, we get 3 times 10 to the n minus 1 plus 3 times 10 to the n minus 2 all the way down to just a 3. Now we can expand these two brackets, and that gives us 10 to the 3n minus 1 plus 6 times 10 to the 3n minus 2 all the way down to 6 times 10 to the 2n plus 5 times 10 to the 2n minus 1 plus 3 times 10 to the n minus 1, and then a series of 3's all the way down to the end. And so what we notice here is that if we write this out as a number, we just get a 1 first, followed by a 6, and a series of 6's, and because here it goes up to 3n minus 1 and starts at 2n, that will give us n digits. Now we have a 5, followed by nothing here, so we just have a bunch of zeros, which in fact is going to be n minus 1 zeros. So in total, this is n digits. And here we have a series of 3's at the end, which is just going to be our n3's. And so we've proved it. That's all for this video. Thanks for watching. If you have any questions or video suggestions, leave them in the comments below, and if you want to see more content like this, subscribe now.